Hi there, it's your host Atul here, and we have another cracking lineup of maths educators here from all over the UK. We're keeping our social distancing well here. We've got different parts of London here, and Worcestershire and Cambridgeshire. We've got Naveen with us, Jemma Sherwood, Danielle Quinn, very own McCourt as well. So we thought we'll kick things off by discussing one. We're all into teaching maths. We'll kick things off by one of those topics that you really like teaching, and it gets those aha moments from students, and we can play along with this on Twitter as well. So just reply to things you like teaching. So yeah, who wants to take that one?
Well, I thought you were going to kick off, Atul.
I'm going to kick off. Okay,
right. Your favorite.
Yeah. Okay. Cool.
Topic.
So I'll kick off without rambling too much. For me, I teach. I do private tutoring one-on-one, so I do quite a lot of intervention work. And for me, the most interesting thing recently has been teaching primary maths, actually. So for me, right now, what's interesting is for students to understand negative numbers using multiple representations. So I find this thing I'm trying to fix in secondary all the time. So like, negative times a negative is a positive, etc. So of course they've learned this as rules, but they have no kind of representation of it. So for me, it's been using these two-sided counters as I got some CPD from it with Johnny Hall's workshop and Bernie Westcott. So I've spent quite a bit of time actually and field testing with a tutee one at a time, and I'm very grateful for one or two tutees who challenge me back, like, I don't understand this, or what does it mean to flip a counter? How can you just flip a counter and it becomes negative? So for me, actually, that area is really, really key, because I even tell them, like, if you know this now, it will be very useful for you in like all of the maths. And I even mentioned the field axioms and what an axiom means, etc., etc. So for me right now, that's a really, really good thing to teach, actually. Yeah.
I love the directed number line to help with that as well. I like it when students realise that you've got this idea of the numbers going positive and negative and kind of almost behaving in the same way, but out from the centre, out from zero. So if you have, say, 2 add 3 and -2 add -3, you see this kind of almost reflection going on. And I quite like that to link with the idea of flipping a tile over and seeing that reflection almost.
Yeah, it's really nice for the teachers, like seeing like the patterns that they can start to spot, or like how proud they are when they start spotting those patterns as well.
When would you guys think about introducing number line? It's quite a controversial topic as to when number line comes in the early years curriculum.
I wouldn't dare have an opinion on it, actually. I'm scared.
It'd be a nice thing on Twitter, yeah. Well, yeah. People on Twitter, when would you introduce the number line?
Is there a reason you can't introduce it from almost the beginning?
Well, that's what I'm saying. It's such a controversial topic. So I hold the view that actually I introduce negative numbers and the number line really very, very early. But it's not a very popular view. It's not a well-received view at all.
But from whom? Well, not names, just me. But internationally, the debate in early years education about when the number line comes in, it's been raging for years and years and years. What's the objection to it being early on with negatives?
Well, of course, negative numbers are extremely hard to conceptualize. So are we waiting for a level of maturation to occur where the conceptualization is appropriate? And there are different camps in this debate around we wait for the conceptualization maturation to occur, and then so people often challenge me about why I introduce negative numbers quite early and why I introduce number line quite early, and I'm doing it because I don't want to introduce subtraction and the misconceptions of takeaway. That's really why I'm doing it. I never want the misconception that you can't do 5 minus 9 to arise, which means I need the range of numbers to exist.
That is the impression I have, that it's very, like, as soon as a child's curious about the number line, it's so natural to want to know what could go before, or they want to know what happens before. Like, it seems if you've piqued a child's curiosity they can't not wonder that. So it seems like natural to be ready to deal with it rather than sort of hand waving like, oh yeah, we'll be able to do that later.
Yeah, it's an interesting debate there, isn't it? Like, it took thousands of years for zero to appear, thousands of years for negative numbers to appear. So civilizations didn't even get to the point of stumbling upon it. But it's a very interesting debate, and you notice marked differences in children who have had negative numbers introduced early compared to children who haven't had negative numbers introduced early. They're markedly different in secondary schools.
Is there an element of the argument that it's easier to introduce parts of the whole on a number line because it may be easier to conceptualize before negative numbers, which are probably more abstract?
Yeah, absolutely. Is a part of a whole is much easier to conceptualize than a negative number, or indeed zero. Zeroness, the absence of number. If you're a young child, well, why on earth would we talk about the absence of number? Why would it matter?
Yes, and early on they're just learned all through concrete objects and countability. Interesting.
Yeah.
Because the negative numbers only exist in reference to the zero, isn't it? So you have to understand what zero is and then define the whole negative numbers. And the way I see it, and also saw on Bernie Westercott's video actually with Craig Barton, was they introduces a number track, so the discrete view of numbers before you get into a continuous view using a number line or a vector view. So that, those are things I also use. I use a number track first before we go on a number line.
Yeah, they are intriguing things, and things like ordinality arose many hundreds of years before cardinality. First, second, third are much more natural things to understand than 1, 2, 3, the countability. If you ask two-year-old siblings who won something, they know who won and they know who lost,
or who's oldest, or the desire for stuff. Yeah,
absolutely. And if you give them,
they're obsessed with it. It's like it's such a human desire to know hierarchy and
ask them to arrange their toys. They'll put them in height order or something like that. Ordinality arises before cardinality is rather unusual, and is true in the history of maths that ordinality arises before cardinality.
Atul, you said an interesting phrase you said that children have to understand zero before they can think about negative numbers. So to what extent do you have to understand zero? It's quite a loaded word, isn't it, understand? Before you can start to deal with negative numbers.
Yeah. I suppose I'm going to kind of throw it back on Mark, because I learned some of this from Mark's book and actually on his CPD courses. So I would construct like 3 yellow counters plus 2 equals 5, and then I'll go down a sequence when then it's 3 plus 1 and 3 plus the absence of something gives you that, and then do that with a whole bunch of them. And then go beyond that, so 3 plus something else gives you 2, but you're still adding. So then I'll put on the field axiom that you're adding with something else that diminishes it or gives it to you. 3 plus something gives you 2, and then I'll spend quite a bit of time on this language to negate or this negative thing. So we give it a symbol, and also become more clear in my language with the difference between subtraction, which is a process of verb, and a negative number, for example. So it'll be
it's amazing how there's an enormous amount you can do before you conceptualize these things. The conceptualization of zeroness, I doubt any of us on the call right now have got to the end of our understanding of zeroness. It's an enormous thing. It's amazing how much mathematics, at all stages in learning mathematics, it's amazing how much of the mathematics we're doing without a fully developed conceptualization of the ideas that are there. So the thing that Atul's describing about through symbolism and pattern within symbolism, can we discern a set of rules? Sure we can, of course. Does it mean we understand all of the symbols in that pattern? Not necessarily. And sometimes we get a little bit hung up maybe on trying to make sure every single facet of something is fully understood before having utility. And maybe we don't need to do that. Like, I don't think I've met anyone who fully understands zero and zeroness.
It's interesting sometimes when you listen to pupils you teach, or I suppose in the case for some of you, your children, your own children, when they're explaining something to someone else, because you find out what the kids think is essential of what's been told to them versus what you thought, either what you thought you conveyed or what you thought was essential. And I always find that really interesting when the children choose to strip it down to, like you listen to like a year 10 explaining something to a year 8. And like, it's just fascinating what they obviously do focus very heavily on procedure and like getting things right. But what they explain is like how to understand is so intriguing as well, because they obviously have such a really stripped back idea. But I don't know if that just reflects that we've really had to strip things back for them as well.
I think that whole idea of listening to what somebody has understood from what you've taught and comparing it to what you thought you'd compare is a really useful one in maths.
It's quite humbling. Yeah,
that's I mean, you get this in one-on-one tutoring because it's live, it's instant feedback, and you get this teach, do, I teach, and then I expect them to kind of repeat back. And the only purpose of that is, can they repeat back what I just taught them? How much can they repeat back? And is there a misconception there? What's their existing view of what a negative number is? So I'll just ask them, what do you think it is? And then it'll sort of pop out of their head, and then I have to either build upon it or deconstruct it, like in the nicest possible way, and then take it from there. So that's
it's good fun measuring the amount of information children are receiving compared to what the teacher thinks they're receiving. It's a really funny experiment because it's really, really low. And it's not just children. If you try to teach the Newton experiment in 1990, where adults are trying to teach other adults pieces of music, and the person teaching it says, of course they've got it. They completely understand this, and nobody understands any of it.
Yeah. And I think that was probably the biggest mistake I made at the start of my career and in my early years, was trying to do so much in a lesson. It was the era of rapid pace and all that kind of stuff from Ofsted. I tried to fit so much in, and looking back, you just think, I may as well not have done any of it really, because how much would have actually stuck?
We kind of went off on a tangent now on your question, Atul, of topics.
Well, I didn't realize it was I mean, it's a great topic, teaching negative numbers, and because we know as teachers, if you get it right from the outset, then a lot of problems further down the line will be avoided. And often what we're doing is trying to fix this idea that there's a difference between negative numbers minus the operations, just the basic operations, like the 4 basic operations. It keeps coming up again at secondary. We can see a whole bunch of scripts.
Do you think, Atul, especially since you're helping, it would be interesting because you obviously get to see more in depth with some children because you're tutoring, is like it's so common for children across the country, they get to year 10 or year 11 and they still have fundamental issues, particularly with negative numbers is a really common one. There just still are problems, and sometimes with 4 operations, but negatives is the one that's just like really hitting everything else. It's hitting their graphs, hitting their algebra, the confidence is just shot because of it. And there's so many ways you can approach negatives. There's so many ways people can talk about it. I do wonder if this is something where, I kind of hate this, but wonder if we should maybe just give it up because it'd be better for the kids. That should we all as teachers have like a much more consistent approach to negatives? Like I know that they're like 20, I don't know, let's say 20, but like so many ways you can explore and show and explain negatives and so many ways to talk about them. But actually is the fallout that we're kind of hurting the kids, because a different kid gets a different explanation every year. They begin doing negatives like so far before Key Stage 4, but then most of them are, not most, but like so many are still in a bad situation. Is this because all of us are teaching it differently? Are we teaching it badly? I don't know. I just wonder if our desire for autonomy and the enjoyable creativity with negatives is actually hurting a significant chunk of the kids by the time they are expected to perform in an exam. I don't know what you guys think.
Yeah, I mean, it depends on where they are. I mean, if they are year 11 and they're doing factorizing quadratics and we haven't got much time, then just teach them the rule. I mean, we all have to do that, right? So, and it's
we,
very
we
interesting.
all have things we're not proud of. It's okay.
Yeah, I mean, I do it as a tutor. I mean, I want them to get a good grade, and I'll have to. I'm not sure what Mark is thinking right now, but teach everything correctly first time around. But
that's why he's wearing the sunglasses, so he can be totally inscrutable.
Right? Yes, yeah. I think it's the poker face. But yeah, you've got to do it because it's a high stakes exam, and it's interesting as a tutor. I get especially as an online tutor, I've got tutees all over the world actually. So I've got US students doing Common Core Algebra 1 and Algebra 2. And what I want to do for my tutees is provide them with consistency. I don't want to teach them one method and they're learning something else at school. So very early on I realized I can't get emotionally attached to my method because it's probably going to hurt them if they have a different method, because they're in a mix-up. So I'll ask them what method they're doing, and I will just sometimes I have to learn what method they're doing, but there's so many different methods. So whatever the teacher is teaching them, the time they have with the teacher is sacred. It's actually I tell them like you should make the most of that time, like, and then you only ask me the things that you're stuck with, and what they're learning at school is very important. So I'm to give them that consistency. I make sure they're learning whatever method it is, whatever representation they're being. I may not agree with it professionally, but I have to, like, the child's welfare is my prime concern, so I'll kind of go beyond that. And
or what they're trying to get from you. If they're trying to get an exam grade at this stage, they're with you, you're kind of stuck with that. Yeah, it
depends if they have time, and if they're year 8 or year 9, then I can go into more things like using multiple representations, and I tell them like what you're doing is one way of looking at it, but what I'm going to show you is another way. So it's the same thing, but you're looking at it from different viewpoints. So as a profession, I suppose it makes sense if you have consistent methods, but I don't know, maybe Mark can.
Yeah, I'm interested to know what you all think.
But it's the problem is it's hugely complex. We're talking about early mathematical ideas. We have a profession all across the northwestern cultures where there is a very strong belief that the one thing that matters above all else is teacher autonomy, and that there are no correct ways of doing things, and that nothing works in education. These are things that have been pushed for a very, very long time. And it's an oddity in professions. Other professions don't really do this. If we are going to insist on, and I don't think we should, if we're going to insist on formal education at 5, and we're going to insist on starting to do arithmetic and things like that, there are known good ways of teaching this, and there are known sensible models and known pedagogic approaches and choices that can be made that will vastly improve the chances of pupils understanding and retaining. We could set those out. We could say these are these ways. We could be specific about the didactics of the mathematics and say this is how this idea works, and these are the best models, metaphors, examples for communicating this idea. And these are the things that will happen to the child. These are the dispositions they will start to display when they're starting to grip these things. And all of this information is known. But as a profession, we continually pretend like it isn't known. We continually pretend that these are things for every individual teacher to work out. I remember when I came to teaching, after having been in industry, I thought it was so odd that no one gave me a manual and said.
I was so shocked. I thought I was going to read the book of how to teach maths. I thought it was going to be like a big book, but I was very excited to get the book, and I was really shocked or you get like a PhD book like Teaching Mathematics in the 21st. You get some PhD book called something, and I was excited because it was big, but all it was like a lot of like reflection. And obviously, as you get more experience as a teacher, the more you realize being a reflective practitioner is. When you're a PhD student, you're like, if someone says reflection again, I'm going to kill someone. But then after you've been teaching a while, you realize actually this is a huge thing. But there's a whole book on like reflecting on practice. But I was like, but what is the practice? Tell me the practice. And it was quite like frustrating. But
and particularly, what does it look like when it's happening? It's a hugely complex thing to recognize learning occurring, and learning occurs over long periods of time. Gemma's talking about that period where, you know, progress had to be achieved in 20 minutes and all that kind of nonsense. It's hard to spot learning occurring. And I was surprised that nobody gave me a manual saying, these are the things you'll notice. These are the changes that will happen to children over time. These are the kind of dispositions. These are the things they'll start saying, and these are the ways they'll start connecting them to other ideas and so on. I thought it was a very odd thing. You know, so we have this problem there. These ideas should and could occur really quite early in a child's development, but we're not helping people to make that happen. And either we believe that a teacher can have a profound impact on a child, either we believe that the act of teaching can change a child and can help them become learned, or we don't. And if we do believe that a teacher can have a profound impact on a child, and we have a current situation where huge swathes of the population leave schooling not even mathematically literate, then the conclusion can only be this is a result of teaching, right? That must be the conclusion. Because otherwise we're saying, well, if it's not the teaching, if it wasn't the teachers and it wasn't what we were doing with the pupils, then teaching doesn't have a profound impact. So we can either get really serious about the fact that teachers can change children and they can help them to become learned and therefore get on with doing that, or we might as well just say, well, let's just leave them to it. It's a very odd situation.
I've got a few more questions coming in, actually, finally. We've got Laura on Periscope. This one's for you, Dani. Dani, on the Mr. Barton podcast, you sounded like you might have cracked the consistent approach. Did you? That was about 5 minutes ago, so we might have lost it.
So by consistent, do you mean across teachers? Or I suppose I haven't seen her question. Do you think that's what she's referring to?
I think so, yeah. So on Mr. Barton podcast.
So it'd be really interesting if Naveen jumps in as well, because she obviously experienced when Naveen and I worked together in the same department. So what we do in our department is we are consistent in all of our methods that we do. We are collaborative in how we decide how we want to teach things. Our department meeting every week, a lot of it will be given over. So we probably spend half an hour together as a week. At this stage, it's a team of 14 discussing how we want to teach specific things, whether it's tiny of how we want to get the language just right, or like what's the core language for describing the spread in a box plot, or how to analyze a box plot, or and we might, for example, a few weeks ago, we spent almost 50 minutes just discussing how children were having slight misuses of language in a box plot. Or, for example, this week we spent ages just discussing, probably about 20 minutes, when we were going to begin to introduce identities and what pre-knowledge we wanted them to have, when we wanted them to use identities, what explanation we wanted them to give. So it is obviously a very intense and nerdy process. But it makes people feel bought into it. I don't know. Go on.
She's clarified 2 negative number rules, actually.
Oh, I see.
Yeah.
Right. Sorry. So with that one, oh my gosh, I haven't had to teach year 7 in so long that I'm probably going to badly misrepresent it. I'm sure some of my colleagues watching her teaching year 7 at the moment will cringe. So this is the thing that we were finding we had the most difficulty with. Children are generally okay with multiplying and dividing negatives, at least at secondary school. So you go into the reasons why and all the stuff we talked about, but as memory aids, they're not too hard. What the children seem to really struggle with, stuff like -5 + 7, -5 - 7, getting a bit boggled at that stage. So what we realized, because we spent probably at this stage almost 4 hours in this department over weeks thinking, what is it we're all doing in our brains that we just know what to do? We realized what we were all reacting to was when the signs are the same, you get the absolute sum of what you've got, and then if the signs are different, you find the difference between, so taking 2 terms at a time. So we explain that to the children, that take 2 bits at a time, and we have it in more of a rhyme, which I'm going to remember badly. The signs are the same, get the sum, and then you just judge, have I got a sum of negative values or a sum of positive values? If the signs are different, get the difference, and look in terms of the absolute value. If you not the absolute value, have you got more of the negative or more of the positive? Which I know sounds a bit like a flow chart, but the children actually seemed to love that. So we realized it was what we were all doing, is we were just looking at something and our brains are saying, just find the difference, just add them. And we're thinking, how did we know to do that? Why aren't we telling the children this? So you spend a lot of time realizing we were thinking of it in a flowchart way. So we should let the children know that flowchart way. And of course, it was preceded by, in our case, a lot of number line work, help them understand why that made sense. That it wasn't just like a random flow chart, but we realized we were doing the kids a disservice by not explaining that to them, because we were relying on it as an adult who were confident. So it seemed wrong to not share that with the children. I don't know if other people hate that, but that's what we ended up doing with the children in the end.
Yeah.
Can I just jump in there as well?
Yeah,
so I remember doing that when I was at the school, and my clearest memory of, I think it was in year 2, it was trial and improvement, and I was just thinking, I honestly have never taught this. I don't know how to teach this. And it was, at the time, me, Dani, and Bodil, and we sat down and we just practiced how we would all collectively teach trial and improvement the same way. And I remember it was interesting because I had never taught it, Dani and Bodil had, and we both picked up different things to improve that scripting. But it meant the next day I could go in and I could teach a lot more confidently. And I was teaching this to top set at that time, and they just, when you've got those kids in front of you, they just know so much. They pick things very quickly. And if there's something that they don't understand, they're very articulate in explaining that misunderstanding or that confusion. And I remember it worked really well. And then I did the same. I used that same understanding and scripting when I went to Great Yarmouth Charter Academy, where I worked for a year, and I used that same kind of language. And that meant what it resulted in is that the first teaching attempt was incredibly successful, and that meant minimal reteaching, which is really, really important, because the more you reteach, the more time you lose, and it's really frustrating in that way. With respect to native numbers, I applied the same approach at Great Yarmouth Charter Academy, and the kids were really, really successful, way more than I expected. So I felt like it worked quite well.
Okay, excellent. Thanks. Laura says that's exactly what I wanted to, Dani. Thank you. We've got Martin Noon again on the idea of consistency. Maybe this one's for you, Mark, again. But can't using consistent methods across the board hamper creativity?
Yeah, this discussion is about who is the most important person in the classroom and what this system is for. Is a maths classroom so that you have fun at work every day and feel good about yourself, or is a maths classroom so that the 30 children sitting in front of you learn mathematics, can be mathematical, can go off and be successful autonomous adults? And I would go for the latter. I worry, maybe Martin doesn't really mean that, but I worry about the 10 years we had of edutainment, and, a good lesson was, as long as, who gives a fuck if they learnt anything, as long as they did it with a card sort, or as long as it was a group activity, or where they made,
or if they were busy,
they expressed a simultaneous equation through papier-mâché, or a graph through their body, that kind of stuff is not, for me, what the maths classroom's about. And this idea of consistent methods, does it destroy creativity? Does it remove teacher autonomy and that kind of thing? Other subjects don't do this. They just don't have this argument. There are things that are right. There are things that are correct. There are methods that work. There are techniques that are true. There are facts. We can just communicate these things. Are there multiple ways of doing single things? Sure. Why do they link together? What are the links? Why are those techniques actually the same technique at heart, and so on? They're the important things. As Naveen was saying a minute ago about this, being consistent about approaches and so on. I often talk about teach everything correctly first time. Teach everything in a way such that it will generalize going forward in mathematics education. Avoid tricks and avoid things that will fall apart. So I don't know if Martin meant that or not, but that kind of debate around, we shouldn't teach them all one way of doing something because then they don't feel creative. As I said, I think last week, Atul, heart surgeons don't do this, right? It just doesn't happen in serious disciplines and in serious training. You don't get heart surgeons saying, oh, but I want to come up with my way of doing it and then I'll feel better about myself. What you get is, here's a standard operating procedure. It works. It always has worked. Follow it. Anyway.
Or I suppose that with operating procedures, they do evolve and change and improve, but that's after peer discussion away from the live patient who's on the table. That I think it's very important in departments and as teachers, we are trying to refine what we do. There are loads of models we have now for subjects or for topics that are so much better than they probably were how can they be? It couldn't possibly be we've got a worse range of options. So things can be improved all the time, but you don't make it just make it up in front of the kids and not share it. If you've got an idea of how to improve, make that part of a collaborative discussion with your colleagues to refine it and check, will this definitely be an improvement on what we have?
And also, consistent method doesn't mean one method. It means being consistent with methods. If you want to get under the skin of 5 ways of doing formal subtraction because you want to explore why all of those things are linked together and why actually the generalization holds true, that's fine. But we're being consistent about the approaches that we take when we're doing that and the ones that we're choosing. And we're choosing them there's a pedagogic choice between, I chose to share these 3 methods with children, not at random, not just so we could all feel good about having a different way, but I chose these 3 methods because there's an underlying principle at work here. There's an underlying relationship in the way these 3 methods work, and I want that to be revealed. And I know that by looking at just one, I'm specializing, and I'm only looking at one very narrow range of where this technique will work. So, when I say consistent and teach everything correctly first time, I'm not saying there's only one way of doing things. It's just about understanding why those techniques work and when they're appropriate to be used.
I also think that when you teach one method really well, the other methods that you use to show an underlying principle have more value and have more meaning to the child. The child experiences mathematics more enjoyably because they're more successful and they're seeing their imagination mathematically widening. So by using one method, which to some degree is foolproof or is really efficient, or whatever goal you want to achieve, the other methods have more value. But just when you teach loads of methods and the kid doesn't know which method to use when, they don't know if they're doing each method correctly, you just leave the child so confused and so demoralized. So part of it is recognizing how to get is like Mark said, choosing a method at that time which you think will be really successful to achieve the intended goal, and that they get it really successfully. But departments can only achieve that if they talk about it. I've only ever really, I think it was at Michaela and maybe a bit at my charter academy where we just talked about math so much that we were able to have the conversation. But if this conversation aren't happening, then you will have NQTs trying their own thing, different from other teachers in the department, and then really every child getting a different experience. 13 classrooms in the same corridor, you're getting a different maths experience in each classroom. It's kind of just a bit of a lottery ticket in that way. So consistent methods give the teacher, in my opinion, more confidence, more credibility, but also gives a child a more enjoyable experience, a more secure experience. That's not saying that maths has to be secure all the time. Sometimes a bit of difficulty is good, but you want to create difficulty at the right time, not on a daily basis.
Success feels good, right? I should just, before we move off that, because the word came up, I should address the word creativity. Otherwise people, because,
Martin's saying creative thinking for problem solving, mathematical modeling. How do you, that
when
kind of stuff,
so I should address that word, because one of the main outcomes of the maths education that we want to achieve, I think, is to create, is to bring about creative problem solvers. But the way in which you become a creative problem solver is to become skilled and fluent in a range of techniques and to know their applicability and utility. So the creativity comes as you become learned. As you become more and more learned and you are able to bring together all of your learning, you can then be autonomous and you can be creative. You can do interesting things. I'm not talking about maths now, I'm just talking about learning in general, right? If you look at the pianist who composes, the ultimate in creativity, and you're composing some new piece. Well, you can only do that because you're fluent in technique.
I suppose there's also the security of knowing how to bring something back. So for me, I suppose as you're talking, I was thinking an analogy for me is with cooking. And I love to cook, but I've only become more creative or willing to do my own thing recently, because I've only recently thought I know how to rescue a dish if I'm sort of screwing up halfway through. Then I have like some rescue methods available. And I think maths there's an element of that they're only willing to be creative if they're sure that they have enough secure understanding that they can judge if their creativity is working. Like children love to test out stuff, but the ones who are most willing to test out stuff have like their own baseline to test themselves against. They want to test it quite privately, like, oh, I have an idea. They often don't put their hand up until they're quite sure it's good. But the only way they're like sure it's good is because they already knew how to test the validity of what they try. So they need some security in the maths, not like total security, but they need some security of what they're doing to give them that emotional security to try a new thing that they can then share with someone else as well, is the impression I have so far.
Yeah.
I'll say, Atul, if you don't mind, one thing I'll sort of launching, because I know, Mark, you're talking about that we kind of valorize in Northwest, or at least in England, the idea of teacher creativity and teacher autonomy. One thing that, and maybe this is something that I've totally misunderstood what everyone's saying on it, and you guys can explain to me, one thing I find really strange is this broader attitude of people need to choose what's right for their kids in their school. And I find that really weird. I just don't get why a kid in Wembley is going to understand equations differently to a kid in like rural Highlands. Like that just doesn't make sense to me. Like what could possibly be different about a kid in Guildford and a kid in Bradford? Like why would they need different methods for negative numbers? It blows my mind. Like, oh, you need to do what's right for your school. It's like, what could possibly be different about the kids you have? Like some kids are black or white or rich or poor, but like, what's that got to do with collecting like terms? I just find it strange. And as I like, it seems to be like this weird catch-all phrase that allows everyone like a get-out-of-jail-free card for doing whatever they want. I don't know. Maybe I've totally misunderstood when people say this. I'd like to know what you guys think.
Yeah, I mean, I get that with tutors all over the world, right? It's some of the axioms of maths remain true wherever you're doing it in the world, right? Like there's negative numbers and there's anyway, we've got questions coming from the floor. Actually, they've started coming in, which is great. We've got Chris Guerin asking 2 questions for all of you. How important are presentation in books and target grades to all of you?
in pupil exercise books or textbooks?
That's all I've got from the question. But yeah, Chris, if you can clarify that, exactly what you mean.
I guess he means exercise.
And we've got another one for Jemma, actually, from Sudeep, Boss Maths. A question on maths subject knowledge. There's a lot of love for SKE courses, Jemma's excellent book, etc. But is it fair to say this currently isn't as widespread as the enthusiasm for various theories of learning and teaching? If so, what, if anything, can we do to promote SKE?
The thing for me there is that you can't have one without the other. If you want to learn to teach maths properly or to teach maths better, you have to have elements of both. So they're not necessarily different things. Mark mentioned earlier about how, I don't know if this was before we started filming or not, but Mark mentioned about how actually we understand maths better when we start to teach it, because we are forced to think about how to communicate it, about how our students will learn it, which links to what Dani was just saying. There are ways that we know that are better to communicate maths than others. And I think the more you understand about the maths itself, as long as you're approaching that through the lens of how would I convey this in the classroom, how could I make this clearer to my students, the two go hand in hand. I don't know if anybody else got anything to add on that.
Yeah, great, thanks. Chris has just clarified exercise books. So to repeat that question,
can I start on that one too?
Yeah.
Should we all do a rating out of 5 on our hands, how much we care about it and target grades? So maybe number 1, how much do you care about presentation and exercise books out of 5? No, maybe 1, 1 or 0.
I'm gonna query you on your wording in your question, actually, Dani.
Oh,
mainly because personally, I don't care if somebody sets it out rubbish or not, because for me, the exercise book is about them trying to get their thinking down, and it's a tool to help them think. And we know that what they're thinking about is the thing that they're going to end up learning. But on the other hand, I think there is huge benefit from teaching students to set things out clearly, to communicate their maths clearly. If you ask them to write an essay in English, you would want to be able to read it and understand it. And there's an element, I think, of being able to communicate your mathematics, because that will help you to think round it clearly too. So I think there's two different skills there even. There's learning the maths and there's communicating the maths, and I think both have value.
I suppose I was thinking more things like, have they drawn their margins, have they underlined a title, and that stuff. But you are right, like the legibility of the maths. And obviously, those kids whose 4s and 9s look the same, you cannot tolerate that. Like, that has to be dealt with every time. But
well, we're very particular on this in our department. We make them, we have A4 books, and we make them rule down the middle and use both columns. Or partly because I was getting fed up of, this is going to be people are going to hate this, but generally boys would write really big, and they would fill a whole page of A4 with maybe 5 lines. And it was just ridiculous, and we were getting through books at a rate of knots. So we cracked down on that.
So you are right, Jemma. I think actually I was being a bit silly that with presentation, I don't care about formal aspects, but I do care about them being wasteful or messy, like the sort of messiness that impedes understanding. But that's more because I feel like them trying to be more formal in what they're writing, or clarity will help me better understand what's going on in their brains, as opposed to being for its own sake. So yeah, I think you saying that's made me realise I was being a bit flippant.
Yeah, but what I'm careful to do in my own head anyway is to distinguish between the presentation is not because it will make them learn maths better. The presentation is for other reasons, but other valid reasons.
Caroline's...
Let's stick on this for a bit, Atul.
No, it's starting to warm up, actually.
And the target grades question.
Controversy, it gets the debate going.
If we stick on this one question for a bit, because I don't think Naveen or I have
sure. We'll stay on this thread. Just going to take a question from the floor, a comment. Caroline Kemakisa is saying to structure their thoughts, and from what I understand, her interpretation of that is maybe the way you write and lay out things. I know, for example, when I'm solving linear equations, I like the equal to stay in one place. I don't really care about like everything else not being too tidy, but there's a certain way in which you lay out stuff that helps that structure. So I think that's what she's saying.
I think something Jemma said a moment ago for me is the nub of this, where Jemma said, when I'm communicating my mathematics, and used that phrase, my mathematics. And I think that's the important part. I was at high school, I was only excluded 4 times from high school. And one of those times was I was very tired of the fact that we seemed to be making a facsimile of someone else's better book. In our books, we had to write extensive notes in all of our subjects, but we were just copying either from the board or from a really good book that existed. And I said to my teacher something along the lines of, I'm not going to do this anymore, but I'm happy to buy that book from you. Because there is a better record of it, and a better record than I will do. And the interesting thing about that phrase, I think, the my mathematics bit, is because I considered that the copying out, the learning of new mathematical ideas, that's not my mathematics. That mathematics exists. It's part of the canon of mathematics. It is the community's mathematics. So I saw no reason for me to communicate that mathematics. I could just take that book, and when I needed to revise, I would revise from that book. But we used to do really long, extended investigations in mathematics that would last weeks. One question would last weeks and weeks and weeks. And I considered that to be my mathematics. And, you would start off with one problem, then you would write and write and write. And I think the communicating of your own personal mathematics is really, really important and needs to be done eloquently, elegantly. The conventions of terminology should all be precise and beautiful. There should be a due respect to the subject. But the day-to-day, I'm being taught something new, and I want you to copy this into your book so you have revision notes. I see that as an utter waste of time, because my copy will never be better than a book of professionally produced notes for mathematics. So that's how I'd split it.
I don't advocate, like, I don't think any of us teach that way now. And I think all of us experience that. I had the kind of crazy experience in Ireland that children buy their own textbooks at the start of the year, and we get to our lesson and we'd copy out the example in the book into our exercise book, and we owned the textbooks. That was even like more hilarious in that respect. But actually, at least for me as a kid, and we do the same in our English lessons, we copy the poem out of the book into our book. But in a weird way, and maybe this is just, maybe I was a slow learner or something, I actually sometimes liked that process. For example, I'd read the example of the book, and you read it so fast, you go, yeah, I get it. And as we wrote it out, I suddenly go, oh wait, how did they get from this line to this line? And that, like, because it was a slow process, copying out, I mean, obviously we're doing it like at reasonable pace, but that there was so much more reflection time in copying out an example. So it's not to advocate it. And the same with the poem, that we'd read the poem, I think, yeah, I get it. And then slowly writing it out, I think, wait, why is that word there? What's this line mean? And there was something, so I'm not trying to say this was like some, or maybe our teachers weren't thinking this at all, but actually I did gain as a kid something from having to write stuff out slowly from the model, because it allowed me to slowly engage with it in a way that just reading you tend to glance. I don't know if that was part of your experience. Maybe you're too angry as a kid.
Imagine the pedagogic choice, Dani. So you have a 1 hour lesson, say, and your teacher has taken the pedagogic choice. I'm going to get the children to copy the poem or the equation or whatever it is. And that's going to take up 15 minutes or whatever it is, for however long that is. The teacher has chosen that part of their lesson. And they may well have been thinking, because actually my experience is whenever Dani copies out the poem, she thinks about this carefully and picks up new ideas. So there's a choice. There's something a teacher could have done. Another teacher may have chosen a different pedagogic choice. They may have said, I have 15 minutes available to me. What I'm going to do is go through the poem and with Dani talk about the key areas here and discuss which bits are important and so on. So it's a,
I'm not advocating we use this method. It was just as you said it, I suddenly thought, why did I like it when my teachers did that? Because it was
loads of kids like it, loads of them.
It's very low effort.
Yeah. Lots and lots of children like it. But as we know, children are very poor at choosing optimal conditions for learning. It's copying. If it is a 15-minute copying thing, you can kind of hide it away. There's no pressure on you. It is still very prevalent across the UK. And even still, nowadays, it's still prevalent that children are writing notes that are dictated. And the pressure that puts on some children to keep up with dictated notes.
That's extraordinary.
Huh. Yeah, it is bizarre. It still happens, but there is a lot of it. Anyway, sorry, I whittle on.
I do. I think this might be a bit against the grain, but when I teach something and I kind of go through, I say like line 1, line 2, line 3, line 4 answer, I do really care about the kids replicating my working on their mini whiteboards, just because I want them to ask me what line they don't understand. Like Dani was saying about when you go through something, you will be questioning why it works, and you'll be proactively thinking about it rather than mindlessly copying. But the reason why I guess I do that is because I want the kids to be able to articulate it without any assistance from me. So transitioning from, here's Miss Rizvi's explanation, here's each line, this is fundamentally accurate, don't do this is inaccurate, don't do that, this is inaccurate. And then you see a child doing it on the mini whiteboard. And some children will be like, I don't want to do all those lines, just do line 1 in the end. But then you risk them missing out on so much mathematical understanding. So I'll be quite picky on that. But when they're doing the mini whiteboards, it allows you to kind of enter their minds and see how they're thinking and see like why is Paris giving no attention to majority of the work, whereas Adam's completely given every single attention to detail in this. But then that results in, like I said, in when they're working in the exercise books, they're doing it without any assistance from me. And that's essentially, I guess you can disagree with me, but you want your students to be able to do mathematics or experience mathematics without any authority figure around them. And if a child can come up with a better way of describing something mathematically, then that's even cooler, right? So with that in mind, I do really care about their working. Whether it's in their books, not so much, but on many whiteboards, I'm pretty strict about that. And learning something first time.
On these whiteboards, Naveen, are they? You initially said replicating, as in copying, or are they doing problems that are associated to the problem you've shown? Are they copying precisely yours, or doing something that is equivalent to the example that you were showing them?
Yeah. So they're doing it's in Craig's book. I would give them a problem which is similar to the one that I've done, but they're doing a different problem.
Yeah. So I would classify that as, then that's me doing my mathematics, right? That is my mathematics. I'm not copying your words and your symbols. I'm doing mathematics, and of course, mathematics. As most learning, mathematics doesn't happen by osmosis. It has to be enacted. You have to be actually doing it for this understanding to come about. So maybe it's just a way of classifying it. I think that, I do, you do, my example, your example, what teachers do, whatever you want to call it. I think the bit where they're doing is they're then working on their own mathematics, even though it's strongly related to the thing you've shown them. And I completely agree. There should be.
And it relates back with Dani's analogy as well. You want the child to undo if they've gotten to the wrong answer, and they're less likely to be able to do that on their own if they don't know all the steps. And that gives them that kind of superpower in some way. I've made a mistake. I can go backwards and find my mistake and then go forwards again. And that gives them so much, success, so much motivation. And that kind of good feeling that you want to have.
That's why I'm so obsessed with the that method of backward fading. I'm so obsessed with it because that's what it enables you to do. It enables you to go down a track of mathematics and then think, oh, actually, that's not gone where I wanted to go. I'm going to reverse out of that and then go in a different direction. You can, however you want to describe it, work your way out of it. Go backwards, undo it. It's a really important thing to be able to do.
Naveen, do you think it's important to explicitly build in opportunities for students to go back and try and find mistakes, rather than just as and when they occur, actually create these mistakes so that they have this opportunity to practice it? Because it's not something that a lot of students want to do, is go back and check their own work.
No, they don't.
No, I think it depends on the topic. So I think there's sometimes when you'll give a spot the error kind of problem and the child's got to see where it's gone wrong. But they're very unlikely to go backwards. But I have many times, I think every teacher makes a mistake live. I have made those mistakes, and sometimes I've built in those mistakes in my lesson. So kids can see, it's okay that your teacher makes a mistake too, and I go backwards as well. So I guess it's more of in terms of my teacher persona, I've built in at times when I've deliberately made a mistake to create a conversation for the kids to go backwards with me. And I think when the kids see that, it makes them feel like, oh, if I make a mistake, it's not a big deal, as long as the bigger deal is not trying to go back and fixing it. So I would try and build in that motivation to go back and fix it. But there were some topics, I'm trying to think, I've done a lot of probability. So I'm thinking, okay, they're going to make loads of mistakes probability because they're just not going to give that attention to detail in certain parts of the topic. For example, percentage probability when the denominator changes but the numerator doesn't, or they both change. That's something that I saw kids make a lot of errors on when I was teaching at year 11. And I would build in those planned mistakes in my lesson and be like, oh, I made a mistake, I'm going to go backwards. This is how I go backwards. So they would see that. But I'm not sure that's the right answer to your question.
No, it's interesting to see that you've deliberately built in opportunities for that to be modelled.
Yeah, I worked with I have to agree with the whole gender thing. I feel like the boys kind of give up more than the girls. Then I taught a year 11 class where I think 80% were boys, and they would be like, oh, miss, I can't do it. And they would just throw everything up in the air, and you're just thinking, oh God, this is so awkward. So then I would just build it in myself. See, I don't throw everything up in the air. You can do it too.
Yeah, we found that with broadly, and obviously it's not going to be true for all kids all the time, where we've taught children ways to set up expectations for a question before they tackle it, or for checking their methods. The girls have been much more willing to at least show on the page that they've done so. I don't know if the boys do it mentally, and I'm still baffled by the underlying messaging that I'm getting wrong, or that we're getting wrong as teachers. That's not making the boys feel invited to do that. But obviously,
there's something about the way in which mathematics is presented as a subject that we as a profession, we have convinced children, and you can prove this. You can survey children; it always shows this. You ask them what mathematics is about, and they will very often talk about getting right or wrong answers, which is an unusual state for a mathematician. It's an unusual thing to hear maths described in that way. And because we have created this feeling that the subject is about getting correct or incorrect answers, if you get a correct answer and the teacher says that's correct, there's no incentive at all to then give any consideration to how you did it and what was going on, the method. There's just no incentive because you feel, I'm at the end, this is it.
Yes.
I remember when I was a child, you'd be in mathematics, you might prove something. It's quite easy to do sort of algebraic proof of some geometric property, and it's a long-winded piece of bloody algebra, but it gets you to the correct answer. And I remember teachers saying things like, that gets you to the correct answer, but it's not very beautiful. And this search for, and you see mathematicians doing this all the time. There are lots and lots and lots of theorems are proven in mathematics, but mathematicians still pursue more eloquent proofs. Even though the answer is known, even though we have it correct, they're obsessed with the structure and the beauty and the elegance of the working and how you got there, the journey. And maybe one of the things we've lost in the classroom is exciting children about the journey. Because if we excite them about the journey, then they get to the incorrect bit. We're not saying, hey, you're incorrect. We can say there's something in there. There's something in that journey that you might want to go back and look at. So, maybe a lot of that bias comes from us as teachers.
Yeah, I feel like it's probably a messaging problem with the teachers that we're ending up with a split, but I just feel, you probably are onto something there. I feel like I can't tell where I'm going wrong. I just know that I am. So it's a good place to get started. Whenever we get to see the kids again, I can start with that.
But I like the one that Mark is about journey. So when I find maths so exciting when, like all the time, but when you bring in previously learned topics into a new domain, and then the kids just think, oh my God, I had no idea that these topics could beautifully align together to create this even more awesome part of mathematics. So just whenever I'm teaching, and I would say, this thing we're learning now, but we're going to learn it in an even cooler way in 6 months' time, or 2 months' time, or next week, or in a year's time. And you just see, using that language of a journey. I know it sounds so waffly, but it just also describes quite an authentic love for the subject. Because the more I learn at maths, the more I resource, the more I realize it's so huge. Even at GCSE, it is huge the amount the kids need to know, and even more so at A level. It gets bigger and bigger and bigger. And I think, and this is kind of an off-piece point, but I think one common mistake is that we teach with GCSE in mind. We don't teach with mathematics as a subject that can be tested and learned at A level, university, PhD. Not saying to teach PhD mathematics in year 11, but so I would always deliberately point out the powers of 11. I'm when I teach it in year 7, I would say the squares and roots that, powers of 11 are really cool because you learn about Pascal's triangle when you get older in A level. And I always make deliberate points about learning mathematics at different points in life. And that journey can be forever going if you want it to be. And you would just see children more inclined and more keen to learn what they're learning at that moment, because it will probably be even cooler next year or in 2 years' time. So that word journey, not limiting it to GCSE and not limiting it to A level. I remember when I was at school, we always there was expectation that we all would study mathematics at A-level, because we were just told the whole time maths at A-level is even cooler than at GCSE, maths degrees even more cooler than at A-level. So it always felt more inclined to continuously keep in mind what you were being taught and see it kind of blossoming in different ways. So a bit of an off-piece point, but
I drip feed that in early, so I always go to my students, when you're doing your maths A-level, when you're doing whatever it is. I was going to say then, Naveen, that was really interesting what you said, because I distinctly remember a realisation I had at some point during the first year of A-level maths. That moment when I suddenly realised that all the stuff that I previously thought were disconnected topics were actually not disconnected at all. And I distinctly remember having that realisation. And you said about how maths gets bigger and bigger and bigger. And I think when I had that realisation, suddenly I realised that it wasn't actually getting bigger. It almost made it get smaller, because this thing over here and this thing over here, they're really the same thing, just approached in a different way, or presented in a different way, or applied to something slightly different.
Yeah. Miguel Pimentel's got a really good follow-up. He says he feels that Naveen's answering the previous question he had, which is a very practical one, which is, how do you get them excited about the journey when we only have 60 minutes max? Maths takes a long time.
Gotta drop it in every single day, like exude that enthusiasm. I don't know.
Miguel's very enthusiastic with his maths. I'm sure his kids get that all the time.
It's a small thing on a daily. It's like throwing out the small stuff, doing something small every single day. I don't know. I think I've met Miguel. Miguel's such an enthusiastic maths teacher that I'm amazed that his students don't think it's a journey already. I don't know. I think it's a part of the schools that I've been into. Like, I remember being told from a very early point in my career, just talk about maths wherever you go. And that wasn't a hard thing. So I'd always talk about it, like in the corridors or in the classrooms. But I feel like I've already answered the question already. Miguel has also said that. He wrote hyper. So yeah, that's it.
So you did, yeah. Yeah.
Could I just bring in something? Because I don't think I quite answered Sudeep's question properly. I just read it back. Because he finished off by saying, how can we promote SKE a bit more? And the one thing I wanted to say on that is I think it's links completely back to what Dani Quinn was saying earlier. I don't know why you called Dani Quinn then. Dani said earlier. For me, I think it's more about a culture that you create in your maths department. So if you have, say, a weekly meeting, then that weekly meeting you should be spending most of your time talking about the maths, talking about how you're going to teach it, but also something interesting that you discovered or something that you'd never quite realised before, because the more you talk about the maths, the more the teachers in the department are going to be inclined to think along those lines.
Yeah, that's interesting.
Just on Miguel's point, Atul, something Jemma mentioned earlier on about it being in A level where you thought, all these things are connected. So one of the things that you can do to inspire them and get them to be a part of the journey is making sure the interconnections in mathematics are ever present, and that you are continually having moments of wonder, where you come across a piece of mathematics which ostensibly looks like it's something brand new, and then you realize, no, this is actually a part of a web of mathematics that I already know about. And now that this new thing has come along, I now know something more about something I previously thought I'd nailed. There's something additional has been revealed about that earlier piece of maths. And then the only other thing I want to say about was to not consider the unit of learning to be 60-minute lessons. Of course, there's structure to the days. But some mathematical ideas, you might play around with them for weeks, and making sure that each of the ideas that you're meeting, each of the mathematical ideas that you're meeting, has a moment of wonder. So if you do a moment of wonder every 2 weeks, they'll be okay. They'll come with you. Just don't leave it 11 years before a moment of wonder. That's the main trick.
Yeah, that's the other thing I was going to say. I mean, just as a case study, what if you are halfway through year 11, you're in a foundation set and you have a very negative view of maths. I've heard this from TTs all the time. I hate maths. So obviously I really love maths, and I find ways in making things click for them in multiple representations and so on and so forth. But perhaps what he's alluding to is also, or even if he's not, but how do we get that in that kind of late stages, or
yeah,
you can
children
do it
don't
anytime.
hate maths. It's a complete myth. There are no children that hate maths. I've never met anyone who hates maths. What they mean is, I hate not being successful. I hate not understanding. I hate feeling disconnected. I hate that somewhere along the line you left me. There was an idea 10 years ago that I didn't grip, and no one ever picked me up and made sure I was okay. But to hate mathematics, I mean, mathematics is an epistemological model. It's a way of thinking. It's about being curious. It's about being excited by being stuck. It's about being interested in the universe and being genuinely excited about unknown. Children love all this stuff. Maybe they just don't realize that that's what mathematics is. And when you hear children say, I don't like maths, within 15 minutes, you can prove them wrong. And the most effective way of doing it is prove them successful. Do something with them such that they feel an overwhelming feeling of success and something that they previously thought was opaque and on their reach. And that's just about getting the pitch right with each individual child. When a child thinks this is beyond me, you've seen us do this, Atul, with kids with algebra tiles and stuff like that. And they go, this is way beyond me. I can never do this. You show them something, it takes you 2 minutes, and they go, why did no one ever tell me that? And as soon as you get that moment, why did no one ever tell me that thing? As soon as you get that click moment, then you've got them. Because success feels amazing. And understanding something that you thought you could never possibly understand feels amazing. And then, of course, you can tell them what maths is. That's what maths is. Maths is just, you're curious about something, you don't know it. The exciting bit is the fact that you don't know the resolution to it. That's why it's exciting. If you know the answer, that's dull as dishwater. But the fact that you don't know the resolution to the problem, that's why it's genuinely exciting. And mathematicians want to attack things that they don't know the resolution to. So, yeah, make them feel successful. That would be my tuppence on that one.
I use maths as a metaphor for life. It's like, you don't know the problem. You don't know if it even has a solution, but you go at it from different ways based on the existing knowledge you already have, or seek help, and you find. So yeah, that's great to know that you can do that. I'm just looking at my timeline of question. There is so we're gonna go off the current thread. We've got multiple threads going on here.
What was that really weird one that someone asked Naveen?
Page 68.
Oh yes, there was do you have the question?
Yeah, I'm looking at the wrong book otherwise.
Or maybe it's page 62.
Yeah, I can phrase it. So this is
what
from
was that
Mohammed.
question? It was very precise.
Yeah. The rest of us can relax for a minute because there's nothing we can contribute.
Yeah.
While you find it, somebody asked about target grades along with exercise books we never addressed. Can I just say, I'm assuming you're all going to agree with me, but they're absolute nonsense and they're not helpful, and we should not be driven by target grades. That would be my answer.
100%. So many kids can achieve so much more than you expect, and so many may have performed fantastically at primary, and there's so many reasons that actually getting them to even move on a teeny bit is an enormous battle. The last thing the teacher needs is to feel like bashed over the head because that child, for whatever reason, doesn't want to progress. So being like getting that kid to a 5 might be like the biggest challenge of the year. Being told that you failed so you didn't get to a 7 is completely unhelpful for the teacher as well.
And it doesn't really.
Yeah, exactly. Yeah.
In terms of what we're trying to do, using that word journey again, we are taking students on a journey through mathematics. What does a grade 7 mean in that? It doesn't.
Yeah.
It's nonsense.
Yeah, I completely agree with that. But because Dani has said the most controversial thing on today's call, I feel I should say I love target grades. Give everyone every child's target grade. I also don't believe that, but I'm just trying to trump. Well, you don't know what the controversial thing was, Dani?
No, what was it?
It'll be like a mini nuclear bomb on Twitter.
Oh, this happens all the time.
Because the thing you said earlier about context, where the child is, whether this part of the country or this part of the country.
You were all sort of silent, so I took that as like profound agreement. Maybe you all disagreed.
Oh no, I agree with you. It's just I know Twitter's reaction to things like this. So
what I might say on there, if we're being a little nuanced, is that every teacher in front of their class will know the way that they communicate well with that class. That doesn't necessarily mean that they have to teach the maths in a different way. And I think that goes back to what Martin's question possibly was talking about with creativity too, because just because in our department we all teach dealing with brackets in the same way, it doesn't mean that it will look the same when you come into my lesson as it will when you go into my colleague's lesson next door, because we're different people and we have different ways that we present these things, but we're still teaching the same methods throughout our process of doing this.
Yeah, and that's the split between pedagogy and didactics. And teacher training has lost that. It went down the cult of pedagogy without didactics.
Yeah, that's interesting.
Of course, we're all individuals. We will, like we were saying earlier on, I go way over the top when I'm saying, I never knew that thing. And I like sort of camping it up and being ridiculous when I'm doing that moment, and someone else won't want to do that. And that's okay. And we will have our different pedagogies. But pedagogy with didactics, I think, is where teacher training should be trying to be. Anyway, has that given you enough time to find this complex question?
Yeah, could you just clarify the difference between pedagogy and didactics? Because I know some of the viewers might not know that. Yeah.
Oh, that's a heck of a big question.
Without a PowerPoint presentation and all of that.
So let's say that pedagogy is this is too big a topic to sum up. Pedagogy is kind of the art of teaching. It's how you are, your dispositions, your teaching style, pedagogic choices that you make around the way in which you communicate and present, and so on. Didactics is the technical detail of the subject at hand. So I would say that, how can I sum this up? Teaching is a transitive verb, right? Teaching has to be applied to something. And what has happened from it's kind of 2010, teacher training had this cult of pedagogy where the thing that mattered was there was a card sort, or it was active, you were dancing when you were doing it or whatever, without applying it to the subject. And where you see this happening, where this is highlighted, you might see in some schools, senior management teams would have a teaching policy or a lesson observation form that is common across all subjects. Now, if you see a lesson observation form that is common across all subjects, that's pedagogy without didactics. Because the thing that teaching is being applied to really, really matters. So I've got zero interest in someone who can teach well. They're flamboyant, they're an exquisite performer. What I'm interested in is someone who can teach mathematics well. Now, you might be an exquisite flamboyant performer and teach mathematics well, and you might be a miserable old sod and teach mathematics well. I'm not doing a very good job of something like that because it's a really complex issue to discuss. And it takes more than a pithy summary, but broadly, the way you are as a teacher and the technical detail of your subject.
I think I know what you mean, actually, because I've got tutor colleagues and I've been in situations where a child is homeschooled and they had a XYZ tutor and they got along well with the tutor and they were not necessarily teaching them the right maths to get them to the right place in the right time. Whereas they could have someone else who they might not like so much, but they actually know the technical elements. They know when to test them, when all the things. They know where that tuty is. That's probably what you're alluding to. Yeah,
well, you're introducing another element there, which is not related to either of those things, which is teacher-pupil relationship. And the impact of teacher-pupil relationship is profound. Even if you are an expert teacher, if you have a poor relationship with the pupil, that can be an enormous bias against learning, huge bias. So now you've introduced another element. So there's pedagogy and there's didactic. Teacher relationship is incredibly important. Really
Everyone would
is.
think teaching is complex.
Yeah, exactly.
That's something I've been thinking about as well, that with teacher relationship, I think we'd understood it a long time as teacher persona, as like, what's the character that the class will relate to? And you're talking about someone who's an amazing performer, or maybe they're very intense, or they have this kind of daddish manner where it's like dad jokes. And those are all personas that can really engage the children. And it's something that I've noticed more as I've watched teaching around the school, that there can be someone who's extremely engaging the children, or maybe very excited or looking forward to the lesson because in various ways someone's engaging, but actually you can still see some children are at a more deep level kind of alienated from that teacher because there's not that other underlying connection going on with each, like, I see you, I value this, I like that you're thinking hard, I see your struggles. And there's almost the relationship's almost like the big picture person that you share with the whole class, but then there's also these like this like secret specialness going on for each child as well.
Yeah, that's so important, Dani. That so I'll use myself as the example. In front of a class, as my pedagogy, I'm really quite flamboyant. I'm quite camp. I'm quite big personality, ridiculous, detailed.
Oh, no way.
Yeah. Almost autistically detailed in everything that I do, but in this sort of strange big personality way. Now I know that big personality is anathema to some children. So then when you go on to teacher relationship side of it, in my class of 30, I'll behave like that in front of the class, I'll do the bit that I'm doing, but then I then know the children who I need to personally intervene with at a very quiet, low level, so that they also feel they have a positive relationship with the teacher as well. It gets really super complex.
And they feel there's something special with you as well, that it's almost like being able to make that change. Like it's such a beautiful thing. I mean, some people do it in different ways. Like some of the teachers who are maybe a bit more serious, or their lessons are very focused journey, but then they'll be going around the class and you just see them like look at one kid's work and they just light up. And that's almost, they've done it in the opposite way to what you've described. Or there's the opposite where a teacher's just so loud or almost to the point of being fun, brash, and they get around to one kid and they're just like so soft, like absolutely, and they're just this new person and they're all saying, I am someone for you. And I just, when you see it, it's like heart meltingly exciting to see that happening in the classroom, and for the kid to feel seen in that way. But
it's super important, isn't it? And one of the things of early career teachers is that you haven't yet developed all of the personalities that you need. So you see a lot of early career teachers, they have one personality. It's the personality they can do at the front, and that's the only personality they can take around the classroom with them as well. And it's one of the things you try to develop whilst you're training is to realize, actually, even though this is working with 27 of the 30, there are 3 that need some kind of different relationship. So it's a very complex thing to ask me, Atul.
It's like all of teaching in some ways.
I add Atul to that, and I think there's a distinction between, as Dani said and Mark said, the person who you are in front of 30 kids and the person that you are with each child. So the person I am in front of 30 children is probably the performance of Miss Rizvi. Like, I'm a performer in that moment. But the way that I'm with each child is probably my more natural, authentic way of being with that child. So I think so sometimes when I'm doing CPD, I'm going into teacher mode now. It's so trainees can see that, it's okay to put on a bit of a different persona of you. So the person that I am as an individual is very different to who I am as a Miss Rizvi standing in front of 30 kids. It's because I need them to learn. I need them to want to learn. I need them to listen to me. So my tone will change. I will behave differently. I'll speak a bit differently. But that's because it's necessary to get 30 different children to listen to me. And that performance is so different. But another thing is, when you have a relationship with a child, you can't fake that. That is something that is not performance. That's something that has to be quite genuine. I think as teachers, teachers love children. We all if you didn't love children, this would not be the profession for you. So I think it's okay to distinguish between the performer, someone that I'm not necessarily on a daily basis, but I am in the classroom, to the person I am with one child as my more authentic self.
I think it's important. It's interesting you use the word authentic, just because I was thinking that too. Because when you say the word performance, it sometimes comes with connotations of inauthenticity. And just like you said, Mrs. Sherwood in the classroom is completely different to Jemma Sherwood at home, but neither of them are inauthentic. It's just different versions of me work better in different scenarios. And as I've become more experienced as a teacher, I've been able to improve each of those sides and in the way that they work best with groups or small groups or individuals and all those things.
And what is something that I've been thinking about with how we help trainees. So it's funny you saying about Mrs. Sherwood at school and Jemma at home, because obviously you're even a different person as a wife than you would be as a mother, than you would be with your friends, and then even with each friend. And that's something I've been trying to help trainees. Part of them being authentic. One thing that started to help them a bit more was I got to get into a really deep conversation with one of the members of staff who joined her school. And her husband's a really effective teacher. He's fantastic and very real with the kids, not real like down with the kids, but the kids experience him as very, very real. And I was talking to her about, because she was feeling very wooden with the kids. And I was like, well, how would you be like with your husband? And she's like, oh, I'm playful, I'm silly. We tease each other all the time. I was like, do that. Treat the kids as if you're just talking to him. And she started doing that. And she became like, she is renowned within the school now. She rips it out of the kids all the time. And they love it, because she's like so sassy with them. But she thought, it was obviously there's a much deeper, more complex relationship she has with her husband. It was almost like getting that realness of how would you act if you're at your most relaxed with someone you really deeply trusted. That's almost what you want to bring to the children, that version of yourself is so, obviously it's hard if your school's chaos or badly managed, it's hard to bring that, but it's interesting how bad management around the school inhibits the teacher bringing that authenticity and realness in the classroom, because you can't relax enough to act as if you're with your best friends or with your partner or with your family in that sense of like ease. So it's interesting how it inhibits.
Children see right through any kind of fake.
They hate it. It's like kryptonite. It's just the worst, isn't it? They despise it. One thing, I suppose, I don't know if this is controversial, this is me being annoying again, a bit like with those written out examples. One thing with target grades we found useful this year, even though it was quite a stressful exercise, was we looked at with the year 11s who didn't get grades in the end in the conventional sense. At the start of year 11, we looked at all their Key Stage 2 results, because we don't use target grades at school at all, for us to identify anyone who we were basically going, oh, bloody hell, he or she did really well at primary. We had no idea, to help us realize were there children who we had potentially allowed ourselves to be ground down in our expectations. So loads of children, and to go back to the stereotype, most often boys, where we'd gotten so trapped in the stereotype that they had and we had of he's a silly boy, for example, that we'd look at the Key Stage 2 and go like, oh, bloody hell, nationally he'd be expected to get a grade A. We had no idea, because we'd allowed ourselves to stereotype the child, or the child had maybe intentionally ground us down into expecting a lot less. And we'd been under the impression that, oh, that's a real success if this boy or this girl gets a 5. Then we'd look at their Key Stage 2 and be like, wait, that's actually for them a really low achievement. What's happened here? And it could be that actually getting to a 5 was going to be a good achievement for that child, but it helped us address our own biases, that we'd maybe let down a child because it was easier to expect less of them, and it allowed us to examine ourselves having gotten trapped into some low expectations. So in that respect, we did find the Key Stage 2 data very useful for having very honest conversations about what we were expecting of certain children, but I don't know if that's the same thing as target grades. And I don't know if you guys have ever done an exercise like that.
I don't think it is, because you're using it to inform you as the teachers, and that's different to saying I expect you to get a grade such and such.
Yeah, because obviously every child's like, I expect a 9, and eventually you revise down a bit until with reality.
I really, really hate all the conversation around target grades though, because so many times I hear people say things like, well, what subjects are grade 5 or what topics are grade 6? And I think there's a real misunderstanding out there. And I don't know, well, I think it comes as a layover from the old GCSE. The real misunderstanding out there about these grades, and even the way they're awarded, and the fact that they're awarded on distributions. And if we take it to the extreme, you could have a whole cohort of children in 1 year, who all performed significantly better than the previous year, and you would still have 1s, 2s, 3s, all the way up to 9s. So to say there's something such as a grade 7 topic or a grade 8 topic it's just nonsense.
Yeah.
Mm.
Totally.
So should we have this? Have the complex question, Atul? I know Naveen is dying for this question.
Yeah, sure. I'll phrase it for you, Naveen. I mean, you've seen it already on Twitter, but I'll just put it out there for everyone else. So very specifically for Naveen, from Mohammed at Bag T. I'm keen to hear Naveen's thoughts and views from a direct instruction perspective of your book, page 62. Impact of teacher-directed and inquiry-based combinations, where you're seeking to strike a balance between the two approaches.
So I'm going to be really honest, maybe at my own fault. I haven't cracked that balance at all. And I think there's this misconception that DI is completely the opposite side of the spectrum to inquiry, and that's just not true. Like a lot of the teaching in Engelmann's DI textbooks, like Connecting Maths Concepts, have areas for discussion, areas for conceptual building and understanding. But because the way that children are assessed afterwards is very procedural and pen and paper by themselves, it's seen as non-inquiry. Now, with the UL curriculum, we have we have very Engelmann's DI approach with our structuring of our examples, the choosing of our examples, the way we structure the sequence of questions that kids do. But we also include a lot of inquiry-based tasks. Now, inquiry-based tasks are different to an inquiry-based form of teaching. Like that I don't do. I just don't know enough about it. I don't know much about to comment about it. But I think for Mohammed, I wrote a blog post about inquiry-based tasks. So I took a task from Andrew Blair's website. His website is fantastic. It's got loads of great mathematical tasks. The way that me and Andrew, and I like Andrew, we get along really, really well. We are very respectful to each other despite our pedagogy being so different. But, he wrote a counter to my blog post, and I have to return one to him eventually. But we include inquiry-based tasks. We do not teach using an inquiry-based method, and that's very different. And I think taking out inquiry-based tasks would be, just giving the kids a disservice. You need children to be able to have an investigation mathematically, but I just have an approach to doing it in a bit more of a structured way. The reason why I do that is because I think about the weakest child in the classroom first. I don't think about the most competent, because the most competent will be fine and I will assist them, but the weakest child needs the most structure. I want the weakest child to have the most mathematically rich experience when they're doing an investigation. And I feel like for my limited time in teaching and understanding, I feel like DI gives me that structure to help the weakest child embrace mathematics in a really awesome way with these tasks. But I haven't struck a balance because it's really, really hard. There's just, like I was saying, before we had this conversation, we came live, I was speaking to Mark about reading a book by Malcolm Swan, and he said to me that, I'm not going to enjoy it because it's so different to my understanding of teaching mathematics. But that's okay. Like, it's okay to try different things. I haven't got the balance right yet. And I think that's fine. I just think it'll take me some time. But to summarize, I would really, if you see mathematical tasks that you really want to include in your lesson, try and do it in a DI way that if you approve of DI and you use DI, don't remove it because you don't think it fits with your principles. It doesn't fit with the way you teach. Try and take the way that you teach and bring this mathematical richness in. I really want to include more of Andrew Blair's stuff. I just haven't worked out how to do it yet. I hope that answers. Mark's dying to chime in here.
Yeah, direct instructions versus inquiry learning. Go for it, Mark, if you want. Yeah.
I've spoken about it in previous ones. I do hope you enjoy the collaborative learning book, Naveen. Even though I think it's a really important thing to do. That we just keep learning and learning and learning as teachers, and that includes reading things that you think are possibly counter to your current position. All of us know, like all of us here right now, everything that you know, absolutely everything that you know is up until this moment, but that'll keep going, right? And that'll keep changing. And so reading books across the whole range of viewpoints in maths education is super important. The thing it also allows you to do is to reject things when you read them. If you read and look at enough research in maths education, you can then spot the things and say, well, actually, that really doesn't stand up to rigor, and reject things. DI inquiry, we talked about this a couple of weeks ago, didn't we, Atul, about, it's just about the right tool at the right time. Of course, there are times where teachers are going to instruct their pupils. Of course there are. Of course there are times where you want to get your pupils familiar with technical detail. You want to get your pupils familiar with a range of procedures. You want to get your pupils fluent in using techniques in a range of ways. And then, of course, there are times where, because they do know those techniques and they are fluent with them, you want them to be able to take those techniques and apply them to a whole range of tasks and tasks that they are inquiring about. The thing I really love about watching pupils doing, properly doing their own mathematics, pursuing their own mathematics, where we talked about this earlier. The thing I love is that for them, they believe this is novel, and they believe that I've discovered something new and I've gone down a path that no one has ever gone down before. The skill of the teacher, of course, is that you have designed those tasks such that they will go off in the avenues that you want them to go off in. Task design is incredibly complex, really hard to get right, where you have all these children and using their techniques, they'll follow a line of inquiry and go where you want them to go. It's really tough to get that right. But when you get it right and it works and they're fluent in techniques, it's a beautiful thing to watch them do. The DI thing, I think, Naveen, that the trouble with part of the debate, part of the trouble with that debate is that when people talk about DI, they might well be talking about teachers directly instructing pupils. But they might be talking about DI as in the single, very limited piece that was included in Project Follow-Through. And that, I think that's where it gets tricky, that if people are saying that direct instruction is this intervention program that we've used in Project Follow-Through, and that intervention program is super effective and so on, well, that's highly debatable if that intervention program was highly impactful. But of course instruction is impactful, and teacher instruction takes a lot of different formats, way beyond the DI that's sat inside Project Follow-Through, which was just meant for this one cohort of so-called needy children and was an intervention rather than a maths learning program. So, I'll shut up on DI.
I think also to clarify, I'm specifically focused on Engelmann's direct instruction program. So when I use the word DI, I always will try and say Engelmann, just so people can realize I'm specifically focused on one niche thing. I think one of the reasons why with Engelmann that I've really, really kind of fallen in love with the guy is the fact that my teaching career has been very much focused on teaching the weakest kids. And I remember feeling like I was failing them my first 3 years of teaching. And then I was very lucky to working with like Dani and Bodil, who taught me a lot about teaching the weakest children in a way that they were successful. And I became better at teaching those weakest children. And for me, it's very much that I feel like Engelmann's DI does provide me a very solid framework in helping disadvantaged children, the weakest children. And more importantly, you get rid of this misconception that these weak kids can't do it. They most certainly can. They've just, like Mark said, they've been left behind. And the minute they start catching up, the rate at which they start catching up, it just accelerates. They learn stuff faster and faster and faster because they finally have those building blocks that didn't exist at the beginning. And DI very much provides for that. One kind of misconception is that with Project Follow-Through, the DI program in the UK and commonly now is used as an intervention program, but it wasn't set out that way. The way that the program is built is for mainstream teaching, but the way that we use it in the UK and we use it now, even in the States, as an intervention program. the way that DI is made is for mainstream teaching, but it's just so against the grain. It's so different to the status quo that many people won't ever try it for mainstream teaching. There are some people who do it as homeschooling, as their only form of mainstream teaching, and it works really well. But it's because it's so structured from kindergarten all the way up to whatever the level is there.
Which kind of links back to things we've been saying before about structure and didactics, and the fact that everything we do needs to be coherent and well thought out throughout the whole journey. When you have a student who will go to teacher A in year 7 and teacher B in year 8 and teacher C in year 9, and they're taught things in different ways without thought to what's gone before or what will come later, that's where we're more likely to introduce all these problems that then, say, Atul was talking about with the year 11 class later on. And actually what we need is coherence and well thought out curriculum right from the very beginning that everybody is part of, and everybody is and everybody in the team is constructing. And I don't mean writing it themselves, but I mean everybody is working together on, so that everybody is, for want of a silly phrase, singing from the same hymn sheet.
I wonder if that's part of why we have this problem that a lot of children don't feel like they're on a journey, because you change teacher each year, and if each teacher doesn't know how previous teachers did it, they can never refer to the past. So actually, that's how you get part of this feeling of like atomization or alienation over time, because if you're with Miss Quinn, she never talks about what you did before in year 8, year 7, year 6, because she doesn't know. Then of course it feels like you just always, everything feels broken up and fractured all the time. And that is another, is that talk about journey. I was just thinking about it. I realized we're stopping them feeling like they're on a journey unless as a department you have that coherence of, you can talk, you know what they did in year 7 and how the teacher might have talked about it with them, so you can revisit those analogies with them or revisit whatever. So you saying this just made me realize this is why it's so important at that level for the children.
And for like, this is another kind of point for consistent methods within departments. It allows the least experienced or the newly qualified teacher to have that credibility in the classroom and that confidence to teach something that they've never taught before, and know the fact that the kids will learn it really well, and that when that child moves from year 7 to year 8 from their teacher to, let's say, to Miss Quinn or to Miss Sherwood, they're going to experience learning negative numbers with respect to simultaneous equations using the same method that was taught in year 7. And that is just so powerful, not only for those teachers and for the department, but for those children as well. That consistency gives that child structure. I can understand people like consistency, but they like it in ways which are somewhat superficial. For example, we're all having the same homework style. That's great, but that's not as meaningful as having consistent methodical approaches to teaching. That will have effectiveness over time, even when they get to A-level.
And we have to push for this in school, because I mean, so much comes from above, which is generic. It's interesting listening to you talk about DI as in Engelman's DI, because the phrase DI is getting quite fashionable at the moment in schools, but generally people...
It's the new mastery, isn't it?
Exactly. And in my experience of it and talking to different people, it seems to be interpreted in terms of things like Rosenshine's principles of instruction, which are generic principles that are supposed to be able to be applied to every subject, but again, it's almost like people are forgetting to look at the subject. And we need to always be pushing to be spending our time on the maths and not anything else. Because if we're spending our time on the maths, then we're spending our time on the thing that's important. And you can kind of go through the storm almost, because you know that this is fashionable at the moment, and in 5 years' time something else is going to be fashionable. And you really want to be kind of carrying on, focusing on the maths throughout all of this, so that you can let all these fashions pass you by and know that you are continuing to do what is working and what's communicating the maths in the clearest way to the students. But it's really difficult to do so when you're being told one year we need to do this now as a school, and the next year we need to do this now as a school. But like Mark said earlier, the way that we teach maths effectively is generally well established and has been added to over a long period of time. But it's very easy to forget that and to move away from it. And we need to remind ourselves to be constant with it, really.
And you can see it in textbooks. You can see certain fashions coming in and out. So I've got 100 textbooks, and you can just see you can spot when the textbook was published because of the fashion that was going on at that time.
Yeah.
So like David Rayner's compared to, let's say, I probably shouldn't drop names, but I love David Rayner textbook. But the textbooks that followed him, they are following fashions, and that means that the subject content is guided by the fashion and not the subject. And that is when you have an ineffective textbook. Like, I believe in textbooks as in the concept. It's just tragic we've had really bad textbooks for so long. If you were to create a textbook that was inherently based on the subject, then it'd be a very different textbook and be useful. With the UL stuff that we make, you know, what guides our thinking as a team is the subject itself. So we teach things that, you know, really aren't taught, but without teaching them, you're not going to understand the concept. One of the best textbooks I've ever seen is Tom Bennison's textbooks, his A-level textbooks. They are chunky, they are huge, but they are genuinely incredible. A perfect example is hypothesis testing with A-level. It's such a hard thing to teach. It's just a hard thing to understand. And kids really, really struggle with it. And I don't blame them. It's a really hard thing to like be taught. But the resources you see online, the stuff you see in textbooks, covers like 10%. And it in a very sly fashion doesn't teach the hard stuff. And that's what you need to resource the most. You need to over-resource stuff the kids are going to find hard because they need the most practice in the stuff they're going to find hard. And many textbooks just ignore that. Whereas a Tom Benson's book, as a perfect example of a textbook, he thinks about the subject, he thinks about maths, and he structures his content in a way that allows children to go down this mathematical journey where they are able to learn a concept in its complete richness, and he over-resources on the parts that kids will find difficult. And that is a textbook which is really incredible, but it's not in fashion at the moment because it's huge, but it should be because it's fantastic. But it's because we're not thinking about the subject, we're thinking about, you know, if I made textbook and wrote DI on it, it'd be like selling like hotcakes. But, you know, that I'm not into a fad. And the way DI is being used, as Jemma said rightly, is that it's a fashion right now. But the way it's being used, dare I say it, is not correct. The way it's spoken about is not correct. And the way it's referred to is not correct either. Like DI and construction are not the same thing, but they're used interchangeably.
And the genericism surrounding it just waters it down, and it waters down the maths as well. It waters down the teaching. It stops you from thinking about the complexities of the teaching.
Absolutely.
Thinking about Mark talking about those like observation forms around schools, I can only imagine some of the horrors that have been how Rosenstein's principles have been turned into generic observation. Like I haven't seen them because I'm in a school that doesn't use observation forms, but it's suddenly given me this like nightmare vision of what people must be experiencing at the moment. Oh.
Mm-hmm. Yeah, those things are bloody awful. That they get into observation forms so quickly. The one a couple of years ago was loads of schools remove starter. You know, they have a lesson planning form pro forma, and it's always the same no matter what you're teaching. Yeah. They had a block that says starters. That block has been removed and just replaced with one that says retrieval practice. Yeah. Well, all they're doing is they're just doing a starter with 5 mixed questions and saying, well, that's retrieval practice. I've seen people start to create lesson plans based on Rosenshine's, taking Tom Sherrington's book and saying, let's make this into a lesson planning one. And then the one that got me most riled is I visited the school and they very proudly showed me a lesson planning pro forma that they had put together based on my mastery cycle. You've completely
you've gone through the full like Dylan Williams cycle of having to like regret having ever published something.
Yeah. The same thing about Dylan Williams, like his level. Like, that's not what I meant.
I feel like you and Dylan Williams and Dweck and all of you could have like a support group for like the profoundly misunderstood and ultimately had our work bastardized by people who didn't understand us, or people whose work has been used as a bludgeon.
It's a tricky old thing. Once you put something out there in the public domain, people can use it however they want. Mm-hmm. And I regularly get people writing to me telling me what I mean. what you mean by this is, well, that's interesting. I wasn't aware of that.
It's the curse of the great artist, Mark, that your work will be misunderstood.
Yeah, it's better to be replicated. It's like imitation, flattery, and all that stuff. It's been great. I mean, we're gonna wind down a bit. The questions are sort of beginning to go down, and we've been nearly a couple of hours. But yeah, there's Anthony, Danielle, Joseph. this lineup is amazing. Hope you're well. Mark and Jemma, thank you very much. Again, Dani Quinn, loved your circle theorem sessions at MathsConf, which is great. So maybe Mark, you can mention what you do at the MathsConf, how we can bring teachers together in person. I mean, I'm doing my best. I do online teaching. This is a technology I'm comfortable with. So, until all of this returns back to normal, I'm playing my little part as much as I can in bringing this technology and connecting everyone together. I'm really grateful for everyone's time. I know first and foremost you are a family member, a parent, and everyone's going through a very stressful time. So very grateful for your time. Maybe you could let us know, Mark, about the MathsConf and how we can meet.
I think more broadly as well, what you're just saying there, Atul, that we've been running for the last 6 weeks all these online CPD sessions at LaSalle. We've been running these sessions that we're doing just now. And whilst things are a bit weird at the moment and a bit tricky for a lot of us, one thing that I've really liked about the last 6 weeks is people have got in touch saying, the online things and the little discussions, they've made us feel connected to the maths discussion, the maths community. I love that. I think, what a really nice thing. It's not just us, like loads of people are doing this, right? Loads of people are running these sorts of things, keeping people connected. And as you all know, that's what we try to do with MathsConf when we run our big events. Hopefully the next one is on the 20th of June. And we've had a few people on Facebook say, you shouldn't be saying it's 20th of June because, you might be promoting behaviors that are irresponsible and whatnot. Of course, that's not what we mean. We're just really, really big fans of optimism and positivity and hope. And we are really optimistic and hopeful it will happen on the 20th of June. But if it doesn't, we'll shift it to a date where it can happen. But at the moment, it's scheduled to happen 20th of June in Oxford. And we hope a load of people will come along.
Might be more boutique than usual.
We had the Manchester one was just a couple of days before lockdown, and it was a little bit smaller than usual. I understand that. I understand why people felt on the day we need to opt not to come. That's okay. But we'll keep running them. We think, I'm barely involved in it, right? I mean, they wheel me out at the start of the day to say good morning, but that's basically it. It's really LaSalle that put these things together, and they make them all happen with, and you guys and others contribute to those sessions and so on. So I feel a bit of a fraud for being labelled with MathsConf because I have very little to do with putting them together. But I'm glad the team do put them together, and I think those 4 times a year where, if you want to, you can come together is a really nice thing to do. So here's to the first post-coronavirus MathsConf, and whenever it may be. But I'm sure we're all looking forward to seeing each other again and coming together again as maths teachers.
Can I just add, if anyone's not gone to MathsConf, totally go. I don't think Mark will say this, but I'll say it on his behalf. I went at the age of 21. That's my first MathsConf. It was the first one that I ever did. And I've tried to go to nearly every single one they've done in England. I can't make it to Wales or Scotland. Well, I went to Glasgow once. But the reason why it's so powerful is that it's probably the most safe, open-minded, welcoming community that you have in maths teachers, educators, trainers, consultants. You get the chance to meet people who you wouldn't necessarily normally meet in being a classroom teacher. And you meet people who are really like-minded, people who are intelligent, people who think, people who speak, people who question, challenge. And, I went at 21, I'm now 27, and I still go. And I remember my first time speaking there, and I was absolutely terrified. I remember telling Dani and just being really nervous about it. And Dani and Berto both being really great cheerleaders in the room. And, if you are someone who's going for the first time, you'll learn so much. But more importantly, it'll give you the chance to create your own thoughts. And then more importantly, you'll even speak at one point. And that's going to be a completely different thing. I remember Mark saying that John Ashton? Mark, am I wrong?
I don't know. Carry the story on and then I'll work out who you're talking about.
one lovely lad. I'm going to change the lad's name. Joe Berwick. He spoke for the first time, and he was awesome. He was so good, and it was just really nice seeing someone who came to MathsConf twice and then was speaking. But that platform exists for people who want to try different things. So basically, go to MathsConf, and Mark will be really nice to you as well there, because you'll be there.
And don't worry, everyone. Naveen doesn't think 27 means you're actually old or anything. So.
Thank God for that.
I know.
My point is that I think.
No, I know. I just love you. Like, and now I'm ancient. I'm 27. It's like, I was feeling possibly desiccated.
I've got Naveen. I've got pairs of jeans older than that. that's not old. Yeah, no, do come along. Like we do want everyone to come along. It just we started this ages ago, and people always say why do we do this? It costs a lot of money for us to do this, and I just thought, wouldn't it be good if we all knew each other? Wouldn't it be really good if we all knew each other in a way that, because you've had a drink with someone, or you've shared some social time with, at those moments where you're at home alone and you've got a crappy year out that you don't want to have tomorrow, or you've got a inspection, or something's gone terribly wrong with an observation. I just wanted everyone to have someone they could email or ring or text and be friends with. And that's all we're trying to do, really. The platform is there for anyone who wants to talk about anything at all to do with maths education. There's no party line. There's no ideology. Come along and share your ideas. And hopefully, even
if you support target grades, you're allowed to come.
even if you want, you can do a head-to-head with Jemma on target grades.
I will be very civil. I won't boo anyone.
It is very
thanks,
civil,
Atul,
isn't it?
Let me say that.
Yeah, in conferences. And just to back up you as well, Naveen, when I went to MathsConf, I was probably one of the first tutors, actually. And tutoring is a very lonely thing, actually. And I do it full time for me, it's a profession. And I had no one to confer with, no maths teacher friends, no one to share my maths geekiness with. I mean, just forget about the rest, like the complete enthusiasm with. And now I'll go to the MathsConf, the Friday drinks, post drinks, club, like with some of the hardcore party people, and it's changed my teaching life completely. And look at where it's got us now. It's got us to the point where I'm on Twitter and we're doing this, and it's because LaSalle had that openness towards tutors. I've tried to go to other CPD events, and they're just not even open to tutors, and this shows that you're open to, there is no party line, and as long as you teach maths, you're welcome to be there, to present, to do whatever. And I think that's such a fantastic community. I know Craig Barton says you should be awarded a knighthood for your services to the maths teaching, and I really totally agree with him. And
well, it sounds like they're mainly about the drink now that you've advertised it. It's mainly about the Friday night drinks and the post drinks.
That's a really nice. That's why it makes it special, because you get there all these nice people are going to speak to and see and get and spend a good time with. The gentleman's name was Ashton Coward. That's who it was.
Yes, Ashton. Yeah. He did one in recently. He did his first one.
Yeah.
And what was lovely about that, so there's a really good example that it was his first one, and another maths teacher who's very experienced, Pete Matturk, did it collaboratively with him. So, if you were coming along and you felt, I do want to say something, but getting up in front of 100 people is a little bit nervous, there'll be other people there and they'll help you out. And the people that I've been so many education conferences over the decades, it's that you don't find a nicer crowd than the MathsConf crowd. They're so welcoming, so happy. Really nice day. So yeah, do come along, everyone. It'd be nice to see you there.
Brilliant. We'll wrap it up there. I'm just gonna end the live stream and we'll have a little chat and say goodbye there. And thank you everyone for your time. Thank you for everyone who tuned into Twitter. The recording will stay there. I'll put it on my YouTube channel so you can see it on any platform. It's still there on Twitter. Because it's still there on Twitter, just ask questions and we'll answer. And we've got another one coming up next week. And see you at that one. So I'll just hit the stop stream.